video, we're going to talk about central angles and inscribed angles. The difference between them is a central angle, the vertex is on the center of the circle. So, and it makes an arc. So this is its arc. Sometimes it's called the intercepted arc. And on a central angle, the arc and the angle are the same. So if this arc is 80 degrees, this angle is also 80 degrees. And when we're talking about arcs, we're talking about the arc measure. We will talk about the arc length later on in this unit, but it's the arc measure. If the arc is 0 to 180 degrees or less than 180 degrees, then it's called a minor arc. And you need two letters to name it. So if this was A and this were B, then it would be named arc AB. But if it was the major arc and it's more than 180 degrees, so if I'm looking at this central angle and that was named C, I'd have to name it with three letters, A, C, B, or BCA, and it would be talking about this one. A circle all the way around is 360 degrees. So if I wanted to find this arc, ACB, I would take 360 and subtract 80 from it, and you would get 280 would be this arc, and it's degrees, and so would this angle be 280 degrees. So that is a central angle and the arcs they make. Now there is another arc called a semicircle, and it is made with a diameter. Remember, a diameter goes from circle to circle, and it goes through the middle of the circle, the center of the circle. And it's 180 degrees. So if this is 180 degrees, so is this 180 degrees. And it is also named with three letters, and this would be ECF or FCE, either one of those. So that is a central angle. Now we're going to talk about inscribed angle. So the inscribed angle, the vertex has to be on the circle. And when we say central angle, that arc that it makes and the angle are the same. But for an inscribed angle, the angle is half of what the arc is. Or we could say the arc is double of what the angle is. So if we know that this arc is 60 degrees, then this angle would be 30 degrees. If I said that this angle was 50 degrees, then this arc would be 100 degrees. We know it's the same thing with the arcs, minor, major, and semicircle. So it doesn't change things with the way we name the arcs. It just means the arc it makes and where the angle is, where the vertex is. We also call this the intercepted arc. So if I had angle ABC, and its intercepted arc, meaning the arc that it makes, and that would be arc AC. So there is this special line with a triangle that has a relationship with a triangle, and it's called a tangent line, or we can say this line is tangent to the circle, and it is related to the tangent we studied in trig, but we're not going to get to that in geometry. That's an algebra 2 or advanced math kind of thing. So there is a relationship, but we're not going to really talk about it. So a tangent line, there's three things we should know about a tangent line right now. It crosses the line in exactly one place, in one point. So if I could zoom in enough, then whatever, this would only touch the circle in that one little point. The second thing we should know about the tangent line is if there is a radius that intersects that tangent line at that same point of tangency, that point on the circle, then it makes a 90-degree angle. And it's not just a radius, it could also be a diameter. But they have to point at that point where that tangent line touches that circle. So it's a 90-degree angle. So you could see if this would be a tangent line if we had like a right triangle and we knew like this was 5 and this whole thing was 8 and we said that this was 6. We could set up the Pythagorean theorem. 5 and 6 are my legs because they make the right angle. And we would just see if these were the same. So 6 squared is 36 and 25. And then we have 64 squared. And 36 and 25 would be 61. And this is not 64 squared, it is 64. And so since that is not a true statement, then this wouldn't actually be a tangent line. But if it were a true statement, it would be a tangent line. But because at the very beginning I drew this as a tangent line, then we would say, hey, it's tangent because it makes a 90-degree angle. But if we don't know if it makes a 90-degree angle, we just make it a 90-degree angle, see if our Pythagorean theorem is true. The other thing you need to know about a tangent line, so we know, hey, it crosses at one point. It makes a 90-degree angle with the radius or diameter that touches at that point. And then if there are two tangent lines that come from the same point outside of the circle, then the sections from the point outside of the circle to the points of tangencies, these would be the same amount. So if this were 15, then this would have to be 15. And on your worksheet you had, we did a bunch of these where we found the perimeter because we had tangents that formed a shape around. So, so that's about it on tangent lines.